Let's learn about electrolysis. Now, electrolysis is part of chemistry paper 1, chemical changes. Okay. Now, if we look at the word electrolysis, what it actually means is to split up using electricity. Okay. So electrolysis means to use electricity for lysis, or to split things up. Okay, and we use electrolysis to split ionic compounds. So we need to revisit ionic compounds from topic 2, bonding. Now, ionic compounds take place between a metal and a non-metal atom. And in this scenario, electrons are transferred from the metal to the non-metal, making the metal a positive ion and the non-metal a negative ion. Now, because these ions have got opposite charges, they have very strong ionic forces of electrostatic forces of attraction, okay, between the individual ions. So we might have a positive ion here, a negative one here, positive one here, and it goes backwards as well. So what we're saying is that there is a strong force of attraction between the plus and minus charges, and these are everywhere, above, below, behind, in front of this ionic lattice. Now, this ionic lattice has strong, very strong electrostatic force of attraction. So let's label these up here. Electrostatic force of attraction. And it is these ionic compounds with their strong electrostatic force of attraction that we can separate using electricity and by using the process of electrolysis. So when we're separating ionic compounds, we're separating positive and negative ions that are in a giant ionic lattice with strong electrostatic force of attraction between them. That's a bit of a challenge there. It's not going to separate very easily. Now, if we've got this large ionic lattice, this substance, this ionic compound, and we want to separate it, well, it's not going to do anything in its ionic lattice form. It's just that nothing can move. They're all in a fixed place because there's a strong force of they're very strong electrostatic force of attraction. We'll put the word strong here to remind ourselves that they're strong. So before we can do anything, if we want to separate these ions, they need to be free to move. And for them to be free to move, we need to either melt our ionic compound or, that should say, dissolve it. Now, if we make our ionic compound molten, it means we melt it to a high temperature to break the electrostatic force of attraction and to make it into a liquid. It's a liquid, the ions can move. We can dissolve in a solvent. And if we do that, then the plus and minus ions are going to be able to move. Ultimately, we need to make our ionic compound either molten or to dissolve it in a solvent so that the ions can move. And when we've done that, what we do is we say we have formed an electrolyte. That is the liquid of our ionic compound where the ions can move. And we take our electrolyte and we drop it into a container like this. Okay, so this is our electrolyte. In our electrolyte now, I'm going to use example of the ionic compound NaCl, where Na is a metal, chlorine is a non-metal, and sodium makes a positive ion and chlorine makes a negative ion. Okay, so when we look at this electrolyte now, what we've got in it are Na plus ions, Cl minus ions, able to move, free to move now, because we either made it molten or we made it, we dissolved it. So in our electrolyte, ions are now free to move, and that's absolutely brilliant. Because now I just need to get all my pluses on one side and all my negatives on the other. So to do that, we can use some electrodes. Okay, so we can now put into our electrolyte some electrodes. Okay, and we can connect them like so to a power source or a cell. We need to identify which ions are going to go to which electrode. So what we have is a positive and a negative electrode. The positive electrode, this is where panic comes in. The positive electrode is called the anode, which means the negative electrode is called the cathode. Okay, I'm going to call this one over here the anode and say it's the positive. I'm going to call this one over here the cathode. I'm going to say that's the negative. So we've got our positive and our negative anodes in our solution. Now, think about the ions, they're free to move. Which ions are going to move towards the anode? We'll talk about the anode first. It's the chlorine ions that are going to move towards the anode because plus and minus attract. And that's what they do, they go that way. And so will this chlorine here, it'll go that way, because plus and minus attract. Now what will happen is at the anode, so this is at the anode, we have chlorine ions. Now these chlorine ions, a Cl minus is a Cl atom that has gained an electron. So what we've got is Cl with its 7 electrons as an atom, and if we give it another electron, it's now Cl minus. This Cl minus with its extra electron, it doesn't want, it wants to become an atom, it wants to get rid of that extra electron because its minus goes towards the anode. And when it moves towards the anode, it says to its little electron, I don't want you anymore, see you later. And the electron is transferred to the anode. Chlorine has now become a chlorine atom. Okay, now at the anode, you'll have lots of chlorine ions becoming lots of chlorine atoms, and there'll be lots of electrons going to the anode. I've just drawn 2. Let's have a think about what's going to happen in terms of to the chlorine ion. Okay, so Cl minus, which is the ion, will become a chlorine atom plus the electron that it got rid of. That's called a half equation. That's a half equation of the anode. And then if we think about chlorine, well, chlorine's in group 7. So if you have a chlorine atom like this, and it's in the same space, which these atoms are, as another chlorine atom, then these 2 chlorines, which are next to each other, will go and say, okay, we're in group 7. I could do with sharing an electron. You could do with sharing one back. And so 2 chlorine atoms will make a chlorine molecule. So Cl plus Cl will make Cl2. Okay, so that is ultimately not the half equation, but it tells us that at the anode, we're going to make chlorine gas. Because the chlorine ions are going to go there, make chlorine atoms. The chlorine atoms are going to covalently bond to make a chlorine gas molecule. And this is why we sometimes have bubbles of gas at the anode. That would be chlorine gas. And if we wanted to collect that gas so we could use it for some other chemical reaction, we could just put a container on it or just collect it off. That's what happens at the anode, and that's a half equation for the anode. Let's look at the cathode. the ions that are going to move to the cathode are the positive ions. So sodium is going to go that way. The positive ions is going to go that way. Now remember what these sodiums are. They're positive ions, which mean they've actually lost an electron. Don't forget, in the ionic bond of sodium chlorine, sodium is a metal, it gave its electron to chlorine. So sodium's there going, I'd love to have an electron. And these electrons that were deposited at the anode flow along. So they've got loads of electrons now at the cathode. So when the sodium ion gets to the cathode, these electrons join with the sodium ion, creating a sodium atom. This then gives us a half equation at the cathode. Now the half equation at the cathode is going to be our sodium positive ion getting the electron from the cathode, making a sodium atom. So these sodium atoms, sodium is a metal, might just accumulate on the surface of this cathode, or eventually they might kind of like fall off the cathode and just accumulate at the bottom of the electrolysis chamber. Either way, we've got sodium metal atoms separated at the cathode, and we've got chlorine gas. So we've got sodium separated at the cathode, and we've got chlorine gas separated at the anode. That was the whole point. We had this ionic compound of sodium chloride and we want to separate it using electrolysis.